Thank you for your patience as we got set up here. Welcome to the Pyed Piper, a modern Python alternative to awk, sed, and other Unix text manipulation utilities. Our presenter today is Toby Rosen. This is a 30-minute talk with 5 minutes reserved for Q&A at the end. Ready to go? Yeah. All right. So please give Toby a very warm welcome.
All right, thank you very much. So I'm going to talk today a little bit about a script I wrote called Pyed Piper. It's basically an attempt to link together with the worlds of Python and Unix, right? So a little bit about where I'm coming from. I'm an associate technical director at Sony ImageWorks, and we do really big films. Currently working on Men in Black 3, and I barely got up here. So it's really an honor to be up here. In the world of visual effects, Python totally dominates, right? So everything has gone to Python. Even heavily compiled code like Maya and Houdini, which are the primary 3D applications we use, all have Python backends. Besides this, all our low-level scripts are in Python, right? So all our image processing technology is in Python, even when we're calling compiled code, right? And also, any new tools we write are also in Python, right? So that's where we are. We're in a Python world, right? Besides that, big studios like Sony and Weta rely on Linux, right? So we have tens of thousands of procs. Sony has tens of thousands of procs making movie magic, right? And the reasons for this are obvious: reliability, networking, stuff like that. And of course, the goal with everything we do is to have mastermind scripts in Python, which are elegantly designed and import modules and all that. But that's not always possible, right? So the reason that's not possible is that we're working in a Hollywood world, and a lot of times we have one-off requests, and these requests need to be done in minutes. There's no time for scripting, right? We have commands like this, and this is not an atypical command. This is simply a command to regenerate proxy images, smaller images, right? So we have to do this extremely fast, in an intense production environment with people yelling at you typically, right? And in the last 10 years, most of the stuff we've done has been with classic Linux and Unix tools. Awk, sed, cut, stuff like that are used to generate these commands, which we then pipe to shell and run on the queue, right? The queue is our 10,000 procs, right? And so it's in this weird environment, right, where we're coding in Python for most of the time, and then when stuff really happens, you have producers calling, we have to do one-off specials. We're going back 20 or 30 years in computer science, right? And it's not to say that awk and sed aren't great. In fact, awk is an incredibly powerful language, and it'll do a lot more than Pyed Piper will. But the problem is its syntax is very old, very old. Born in the 70s, perfected in the 70s, and it's sort of hard to learn to do basic things, right? And that's where Pyed Piper comes in, right? So I'm just going to walk you through just a few basic things, right? So if you're a command line shell, you echo hello world, right? You get hello world back. Now the difference here is that P is actually a Python string object, right? So it has all the methods available that you would typically have in a Python script. You can now use them on the command line, right? So Pyed Piper follows a general rule of closely mimicking Python behavior. So for example, commas here will add a space. If you add a plus, it'll adjoin them. You can do simple things like replacing, stuff like that. You can select characters. And the thing we've done with Pyed Piper is add extra functionality by overloading the string object, right? So once we discovered that we could overload objects, the next thing that we wanted to tackle was how do we do simple parsing? And simple parsing is what we do most of the day. So we wanted a very simple way to do things, right? And so in the past, you use awk, you're sort of guessing at what field is interesting. With Pyed Piper, it goes into analysis mode as soon as you generate a list, right? So it clearly labels stuff so you can pick them out, right? So if you want field 2, you get field 2 right here. Like that. You can see you can join things together, which is the next most common thing, and you can see it's starting to get really ugly, right? Because you're having these nested parentheses. So that's just something to notice for now. And so what we've done to sort of facilitate splitting operations is to pre-generate splits, right? So it's so common that we have a variable called slash, right? And that does the same as splitting on slashes, right? We also have a shortcut S. These are all equivalent, right? And you can use these shortcuts like this, select the field you're interested. It's very easy, right? So we found this is somewhat unscientific analysis, but over the years, we found that there's just a few meta characters that account for about 90% of the splits. So all of these have their own shortcuts, right? And the yellow part is just the single digit. You can type, or double digit in the case of comma, to get a pre-generated split, right? So we worked with this for a while, and it was incredible. Like, we were able to do so many things that was very hard to do with awk. But the thing that we found is that eventually we'd get these horrible nested parentheses. It was very hard to figure out what the order of operations is, hard to read, and also it's hard to type because you have to keep going back, put in like, this and that, and hard to figure out. And so what we did is we stole from Unix this very basic principle of piping, right? And I'm sure most of you guys know. If you don't know, this was actually one of the key innovations of Unix, which is the ability for Unix programs in any language to put out standard out, program puts out standard out, this program reads in standard in, just keeps going. It's a very simple and elegant way to transfer data, right? And so we stole that, and now we're able to pipe within Pyed Piper, right? So this is the simplest example. You have a string here, pipes it over, you still have a string, right? And so you can see that when you have a very complex statement like this, where it's very hard to figure out what's going on, you can linearize that, right? So you can go stepwise, right? And go, I'm going to do this, I'm going to do that, then this and that. You can see here each of the types. These types are preserved. So basically, whatever this evaluates to becomes the next P. Whatever this evaluates becomes the next P. So it's basically, there's no change in functionality. It's only a human accessibility thing, right? You can now easily figure out what to do and work procedurally down the chain. So next thing we found out was that, okay, it's hard to join stuff together, right? And having this option of pipes opened up two incredible avenues. The first of which is we know exactly what the type is here and here, right? So if we split something up, we get a list, and then we pipe the list back to the same variable, and it interprets that as a join operation, right? So no more nested parentheses for this type of operation. This was a big deal because this is like what we spend most of our time with. We get incredible amounts of data from our existing programs. We have to parse through it on different meta characters, rearrange the text, and then keep going on, right? So you can see you can pipe to a different meta character, and you get this. And in fact, you can do much more complicated things, and Pyed Piper correctly interprets what you're wanting to do. So if you're dealing with a string and a list, it doesn't touch the string, but joins the list together, right? So this is very critical. And one of the key things that Pyed Piper does is it also allows you to print out a string and a list on the same line, which is very useful. It's something that you can do in Python, but you have to recast things and stuff like that. We found that it's much easier if you could just see the list, pick out your critical data and keep going with it, right? And so, of course, we have the same set of meta characters for joining operations. If you pipe to any of these, you get a join operation. The other avenue that it really opened up was the possibility to go back and procedurally get at any of your subresults, right? So these are all stored in a history array, right? And if you need to go back to a particular item that you've already generated, you can just go back and say history 0, history 1, or H1, H0. A simple example of this, and probably the greatest use of this in actual practice, is generating, say, rename commands. So in Linux, you can work towards your final naming, right? Say it's 30 steps. And at the final step, you want to do a move, right? You just go back and refer to the first input, history 0, right? And we have a special variable for that, original. So we found out that it's very common to have to use a split up original input, so we have variables for that as well. So that's pretty much it for the string functionality of Pyed Piper. A lot of times you want to use Pyed Piper to look at an entire array of inputs, right? For example, you want to do a comparative analysis. You want to sort something. You want to pick out the 5th line, pick out the 9th line, pick out a subset of your inputs, right? And with this, Pyed Piper has a variable called pp, right? And essentially, as soon as you go into pp, it goes into analysis mode, where it prints out, okay, this is the 1st line, 2nd line, 3rd line. So you know what you're dealing with, right? With pp, you just do any standard Python function, right? So pp.sort. You can pick out individual arrays or individual members. We've overloaded the list class with very common techniques. For example, if you want a unique member, if you want only unique items, you can use pp.unique. Also, the typical thing is for any Linux utility to delimit things on new lines, right? But a lot of times that's not what you want. The most critical thing is delimiting on something like a colon, like from classic databases. So you can actually rearrange the entire data set based on a different delimiter. We have other things where you can find a string and print so many lines after that using after or before. Once you figure out what you want, you just pipe back to P, right? And then you go out of analysis mode, and they're essentially strings once again, right? A lot of times you want to do simple math. You can do that. It's all run in Python. You have to obviously recast things, right? Once the recast, we get a special output telling you it's a string or a float. Recast it back to a string. You can do some interesting things with standard Python stuff. For example, this is like a spreadsheet function. If you pipe in a bunch of numbers, you can sum them together using a list, right? The final, not the final, but one of the most critical things we also found was we needed something that was grep or something that was like egrep, which is basic filtering. And so what we did is we hijacked Python's normal function in terms of Booleans, right? So a lot of methods, as you know, return true or false. We have a simple rule. If it's true, you keep the line. If it's false, you lose it, right? So here's an example of just very simple Boolean logic. We've added a bunch of common things, which are basically keeping things with particular strings or losing things. There's also regular expression versions of that. And I should say things can get extremely complicated. You may have a very complicated test where you have to do parsing and figure out a particular field, whether that's true or not. Whatever that returns true or false, you get the original output, right? So you can filter based on a very surgical attempt to get data and then get the original output. So far I've been talking about standard in, right? So that's how we get data into Pyed Piper. It's a standard Unix way. There's actually two other ways you can do it. Use a file input, right? And then you get a new variable, TP, which is for text P, and it works the same way as normal P, right? So you get normal, and then you get your text. Second stream input is probably more interesting. You can have statements separated by spaces after your Pied Piper command, and those will be input right next to it as well, right? So it has a whole variable set for that. We have two list variables, FPP and SPP, and basically any operation that you do on these will stick, right? So if you want to sort all your file inputs, you just do fpp.sort and then continue working with it, and this FP will be the sorted, will represent the sorted file array, right? If you want to combine your second stream input with your file input with your standard in, you just add them together, normal Python list addition here, and you get one new long PP, right? So there's 3 ways to consolidate data within Pied Piper, right? So we've overloaded a lot of the basic functions and methods in Python for stuff that's like very common, right? So if you need to get a directory, you just do p.dir and it gives you everything but the last entry split on / p file, obvious, p extension. You can do some level of regex and return particular items of interest using standard regex. Also useful is a line counter, which just every line, first line is 0, second line is 1. Lets you do simple math with these, and if you need to number your inputs, you want to number your files based on something. This is an integer and it allows you to add, subtract. It's a datetime object, which is just a standard Python thing, right? Probably the thing that's been really the most helpful is Pipe's persistent workflow. So first of all, if you pipe data into Pied Piper, it's immediately cached to disk, right? So if you have a long running command, you just pipe it into Pied Piper, use -- rerun, and it comes up. You can cut and paste from an email, it just buffers, you just can rerun it, have the data instantly available. And probably this is the most exciting for us at Sony, which is basically an intermediate between a full script and having a complex set of shell commands. Basically, it just allows you to save however complicated your command is, to a text file, and then if you ever need to use it again, right, you just say my macro. You save it, my macro, comes back my macro. And this is a total black box operation. So basically every time you have my macro, it substitutes your complex command in there. So you can use it as an intermediate, in a very complicated array to get stuff in and out. Right, and we have a whole set of flags to deal with, deleting stuff, adding stuff, searching for things based on username. I should say that there's 2 ways to set this up. The default is it just saves it to your home directory, but there's also a group setup mode where if you're working in a group of people, and you have to trade things, you can just save it to the group and your other group members will have access to that, right? Just a few words about Pipe's internal machinery. Basically, it's all based on text parsing. And the first thing that happens is obviously your command is split up by pipes. We then split up by plus and comma. And the reason for this is we want to preserve the ability to print a string and an array on the same line. So we figure out when you're trying to add things together and when you're trying to add a space, and then that's recreated on the final output. The useful variables, splits, joins, stuff like that, are generated. And then it's just an eval that runs on the input with your command and the variables. You get your output, right? This is added to the history dictionary. And then finally, everything's joined back together with pluses and commas to preserve your original intention of string formatting, right? This is recursively fed back into pipe, and again, stored in the history dictionary, and then you get your final output when it runs out of commands. So one of the key things that we did was to recognize that Python's basic classes were easily overloaded, right? And so Python, Python has incredible functions, but there's a lot of stuff that you don't have access to. It wasn't designed for typical use, but is extremely useful in day-to-day operations, right? So like pkill is one of them, p.dir, all these things. So we found out that it's very beneficial to overload these things. And we also found that a lot of users and like facilities wanted to overload the functions with proprietary code, their own personal functions and stuff. So we made a config file that was very easy to modify. Like, for example, this is a function, that just does a simple print, right? It's just a few lines of code, and when Pyed Piper picks that up, it overloads string method, and so you're good to go with this new function. That's pretty much it. I hope you guys agree that Pyed Piper is pretty useful addition to the arsenal of Unix commands. We found that a lot of people either use it completely by itself or in a combination with other Linux commands. Like expert users will use particular things that are just much easier to do in Python and then keep their awk and sed statements. I'd like to acknowledge a few people. Development manager Andrea Pace, CTO Rob Radow, who both of these people have been exceptionally helpful. My leads over the last couple of years, Greg Newman, Mark Detail, code reviewers Zach Connolly and Patrick Clark. My entire alpha team, which is too long to list, but gave me a lot of great feedback. Stephen Winters, who documented all the help files. And this original project started with a long argument I had with Miles Todorov about which was better, Perl or Python. And he sort of won it because Perl is so much better at the command line. So this is sort of my answer. We're working on an upcoming video right now that's a very good tutorial in Pyed Piper's use. That's it.
All right, if anyone has questions, please come on right up to the microphone here, and we've got a few minutes for that. And then lightning talks are going to be in the track 1 big ballroom in a little bit.
So first of all, this is an amazing tool. I really love it. 2 questions.
Yeah.
One is if you have any data on how more efficient this is as to tools like awk and grep. Like if commands are like shorter by like how much?
Yeah, you mean in terms of runtime?
Yeah.
This is definitely slower. So
Okay.
Typically you don't see, like for the amount of files we do, it's not appreciable. But if you're doing like hundreds of thousands of lines of code, sed and awk will be a lot more efficient.
Okay.
So.
And the second question is, why is this not on PyPI yet?
I don't know. I'm in production, man. Like
Okay.
I'd love to.
Okay.
Yeah.
Thanks.
Does pip have any special abilities to spawn other subcommands underneath it?
What do you mean?
So one of the things, for example, when I'm thinking of command lines is xargs is almost always part of my invocations to spawn it across multiple processes.
Yeah.
I was wondering if I could take an input and process it within pip across multiple processes, for example. We
have an in-house tool at Sony that does that, but it hasn't been released. But internally, no, it's just a pretty linear thing.
Okay.
So we're looking into open sourcing that.
Okay.
Yeah.
I may have missed it, but did you
Yeah.
say where this is available if it's not on Python?
Yeah, I'm sorry. It's available at the Google source page. If you just search for pipe, it'll come up right away. Yeah. All right, thank you.
Anyone else? Yep. All right? No? All right, thank you, everyone.
Thank you, guys. Thank you very much.